This is chapter 3, problem number 4. And the first thing you want to do is find the domain. Well, it's just a polynomial, no denominator, no radical. So the domain is just all real numbers. Now the x-intercept is where x squared minus 1 cubed equals 0. If you take the cube root of both sides, that says that x squared minus 1 equals 0, x squared equals 1, or x equals plus or minus 1. So the x-intercepts are plus and minus 1, 0. Or, I didn't ask you to write it as a coordinate point. You could have easily just written this plus or minus 1, and that would have been fine. Now, y-intercept, that's when x equals 0. So that's when 0 squared minus 1 cubed, which is minus 1 cubed, or minus 1. So that is x equals 0, y equal minus 1. And then we want to look for maxima and minima, and here's your first derivative. So first derivative, and I'm going to bring a separate sheet of paper because I've written on this thing. I don't have a clean page. So f prime is max min increasing, decreasing. That's what f prime gives me. And I'm given that f prime of x is 6x times x squared minus 1 squared. And this tells me that x, and we set that equal to 0 to find the critical numbers. This says x equals 0, and x squared minus 1 squared equals 0. X squared minus 1 equals 0, x equals plus or minus 1. So I have three critical numbers, 0 and plus or minus 1. So now, by the way, plus or minus 1, because if this thing is squared, these guys are multiplicity too, so there's no change. But if you don't see that, that's okay too, because you can just pull test points. So I'm going to pull x equal 2. And at 2, I will have 6 times 2. No matter what, 2 squared minus 1 squared, this thing, no matter what, is always positive, because I'm squaring it. That means the only contribution is going to come when this guy's negative, because this thing's always positive. And in this case, this is positive. And if I put in 1/2 times that thing squared, it's also positive. And if I put in negative 1/2, now I've got negative. And if I put in negative 2, again, times something squared, that's also negative. So decreasing, decreasing, increasing, increasing, increasing. So the only thing I have a minimum here. So this is telling me that I am decreasing till I get to 0 and increasing after 0. So this is negative. So decrease, increase. And my minimum is at 0. So now I can fill in my blanks. It has no maximum. It has and I only asked you for the x values, and that's to save you time, at 0. Inflection points is the second derivative. It's increasing from 0 to infinity, and then decreasing from minus infinity to 0. And now we're done with the first derivative. So now I move to the second derivative, because f double prime is going to give me inflection points, and concave up and concave down. And in this case, f double prime is 6 times x minus 1 times x plus 1 times 5x squared minus 1. And so I set that equal to 0 to give me my critical values. So what does this give me? Well, this gives me a 1. This gives me a negative 1. And this is the sucker right here. 5x squared minus 1 equals 0. This is where I need for you to have grown mathematically. 5x squared equals 1. Or I could use a quadratic formula on it. But x squared equals 1/5. Take the square root of both sides. Don't forget the plus or minus. X equals plus or minus the square root of 1/5. And the square root of 1/5 is a number. And you could use that number if you wanted to. That way with my calculator. There it is. My graph and calc on my phone. So this is going to be second square root of 1 divided 5 is going to be about 0.4. And I need that when I'm graphing, because square root of 1/5 has 0 meaning. So now I've got 4 critical numbers, all multiplicity 1, by the way. And so it's going to be negative 1, negative 0.4, positive 1, positive 0.4, positive 1. All multiplicity 1, so it's going to change all the way across. So 0 is available to me as my test point. So 6 times 0 minus 1 times 0 plus 1 times 5 times 0 squared minus 1, positive times negative times positive times negative. And it looks like positive, negative, positive, negative. It's going to be positive, negative, positive, positive, negative, positive. All multiplicity 1 is going to change signs. So what does that mean? Concave up, concave down. This is an inflection. Concave down, concave up. This is an inflection. Concave up, concave down. This is an inflection. and then concave down, concave up. This is inflection. So I have 4 points of inflection. So I'll fill in the blanks. Inflection is plus or minus 1 and plus or minus the square root of 1/5 or plus or minus 0.4, either way. Twisty little devil. Very simple, but twisty. Concave up from minus infinity to negative 1, then turns concave down from negative 1 to negative 0.4, then moves concave up from negative 0.4 to 0.4, then concave down again from 0.4 to 1, and then concave up again from 1 to infinity. Nasty old guy. I don't know how to, I don't know if I have your test here or not, or a version of it. Yeah. Nope, I don't. Oh, no, going down is not. Going down. On this paper I wrote on. Okay.